Friends, we move the new session. We are coming to the theoretical part, and I would like to invite also Professor Moon to manage this section. And now the session 9, the standardization of 3D medical models. As you know that one of our project intellectual output is standardization. And in the project manner, we collaborated with IEEE MBS, Standard Association Group, and to provide some documents for the standardization of the models for medical applications. First of all, we will chair this session with Professor Yang Li Moon and Professor Alberto Polozzi from Italy. And I would like to invite, first of all, Kuntay Aktaş and his colleague also Murat Eğri and Mr. Osman. He is here from BTEC company. They will introduce themselves better than me. And he will talk about the Mimics Innovation Suite by BTEC. This is important for us because we used for all materials the Mimics suite creating the 3D modeling, and this is very important for us. Kuntay, please.
So now it works?
If you talk in handle, it will be better.
It's a small session. I mean, I can...
No. We are recording.
Okay.
We need
So,
your voice.
all right. Okay. So now everyone can hear me right now, I think. So thank you for having me here. So I'm going to talk about a little bit about the 3D printing and medical modeling. So it's not just about actually the Mimics, but the Mimics is one of the most important tools that we use for this kind of modeling. We are using 3D printing technology for various applications. One of the most important one is the medical 3D printing. So it is one of the fastest growing and fastest improving technology globally. So I prepared some slides regarding to some cases that we have done so far, and also a little bit about the background that how we do this kind of modeling and implants and the guides and so forth and so on. So to begin with, my name is Kuntay Aktaş, as Dr. Emre mentioned. I'm a mechanical engineer, and I also have a degree on the bioengineering. So I am working as a general manager of the BTEC company. Sorry, the images has been lost, I guess. We have two offices based in Ankara. One is the manufacturing, the other one is the management and the engineering team has been working for. So we are working in this field around 7 years, and 7 years ago the 3D printing was really at the early stages. So we had a chance to involve in many projects, which are some of them globally, you could say the world's first studies. And these pioneer studies, after these pioneer studies, we had like 10 awards in 10 international, 2 international and 10 national awards so far. And some of our work has been involved in some documentaries like BBC Earth and Discovery Channel that I will briefly talk about that. So now I'm going through the part of the case studies that what basically we are doing with the 3D printing. Most 3 application that we use 3D printing is the anatomical models, which is also a topic of today. The other one is the surgical guides that we prepare or simulate operation on the computer with the analysis and a lot of measurements, and that we put this pathway to do real surgery. The last one is the patient-specific implant, like you see on the picture. Why we use BEAT technology? I mean, one of the things that is important to surgeons and the patient is that the surgery risks are quite small when compared to conventional way, because what you do basically is preparing everything on the computer with the real rational data. The other one is the faster healing because somehow you reduce the time of the surgeries. The plug and play implants means that, I mean, in the past, what you need to do in the complex surgery is to making a lot of modification or changing the anatomy or the implant in order to fit to the anatomy. But now every implant is designed specifically for that case. That means you can directly put it into the place and just screw in, then that's it. That's why we call it plug and play implants. The other one is the lower hospitalization cost. This is quite important for the reimbursement because one of the barrier that we can talk is that cost of the implant is a little bit higher than the regular ones. But when you look at general hospitalization cost, like the rehabilitation, hospitalization, and the surgery costs, etc., when you use this kind of technologies, your actual cost is actually decreasing. I apologize again because I don't know why, but some of my images are missing here. Why medical 3D printing is quite important in this field? The answer is that it doesn't really matter if you're printing 50 of the same part or 50 of different parts. And when you look at the medical industry, you realize that every patient is different and every case is different from each other. So what you need to do is to customize the solution or the treatment. So this give us such an opportunity that you can stay in the low cost but still give a patient-specific treatment or patient-specific solution in a fast and an accurate way. That's why medical 3D printing is growing very fast in the industry. And where we use this technology is that, of course, the reconstruction surgeries are the most important one. Tumors, traumas, orthopedics, bone defects, and revision surgeries. And of course, another part is the training, which is the most important topic of today. How it works, I hope my video works. No, it doesn't work. If you can give me a moment, I can try to understand why it's not working. Just a second. No, it's not working. I'm really sorry about that. Just a second. One more try. Ben bir yardım alabilir miyim? Şurada falan mı bir sıkıntı? Heh, şimdi geldi. Okay, now it works. I apologize again. So this is how 3D printing is working. I mean, when you compare with the conventional method, the technique is you merge the material layer by layer so that, I mean, you can start from the zero and go to a real material. So biggest advantages is that you can not only design anything that you want, but also you can put some internal designs into your parts. For instance, here it puts some porosity for the bone growth, and you can also use that for another purposes as well. So how the patient-specific implant works, this is the workflow. So basically a patient comes to a hospital or any clinics. It starts with the radiologic imaging. So we take these 2D images, which are, for instance, the X-ray or CT or MRI, whatever it is, we convert them to 3D models by image segmentation. And whatever the patient needs, such as implant or model or guide or training model, we can directly print it or prepare them for the patient. So as engineers, I mean, it's always for us a trade-off between the low weight, high strength, and high efficiency, because our goal is to have them all, but when you have the low weight, you usually lack of some high strength or high efficiency, or if you like to have them too, usually you do a trade-off. But additive manufacturing, which is the industrial name of the 3D printing, give us an opportunity to have them all in one hand. That's why it's growing or disrupting all industries. So when you start with the case one, I mean, this is a case with a tumor in the mandibular, in the lower jaw. So the basic treatment is taking this tumor part and replacing it with another, you could say, a bone from the body. So this is the fibula, another bone in the body. The surgery is that you split into the parts, take it and move it to the jaw and place it, and the idea is to have the functionality of the jaw again. So this is basically what's being done. But the struggle is that when you try to do it during the surgery, usually it doesn't work because of the stress of the operation, the risk of infection, the other risk. You do not really care about, the surgeons do not really care about the cosmetic or aesthetic of the patient. That they usually think about the functionality, and almost 95% of the patient has an asymmetry problem. But now in the mimics, we have all the images, converted them to 3D models. We take the fibula and we make a surgery plan that we understand how much portion of this bone we need and how big should they be. And after that, we made the fibula reconstruction, and this is actually what we planned before the surgery. And the good thing is that almost 95% accuracy we received after the surgery. This is exactly that we planned, and the left one is exactly the same as we had before the surgery. The another one, like a shotgun victim or this kind of reconstruction, basically you don't really have so much option if you are a reconstruction surgery and you have such kind of cases. But thanks to this technology, we can mirror the other side of the body and design a patient-specific implant from the patient's own information. And this is very important for aesthetic and functional concerns. So basically what it will look like after the surgery, and it was a successful surgery, and we made a lot of analysis and measurements in order to understand what is the right position of what kind of change we have to do on this implant. The another one, the very common and what we do in a very straightforward way, the cranial implants. In case of a tumor or an accident or any reason, if the patient lost some portion of his head or skull, we can so easily design a cranial implant which is made of titanium, which is a pure titanium or perfectly biocompatible material. It's really helping surgeons and the patient to have the best treatments ever have been done so far. The another one, the mandible revision. This is one of the things that I was trying to tell you. He had a surgery before. They moved the fibula to his jaw, but of course, as you can see, there's a lot of asymmetric problem which causes a lot of pain in the jaw and in his face. So basically, we made another planning to show the surgeon that what kind of parts in the fibula he will need again, and after the surgery we can plan everything where the jaw should be cut, and these are the guides in order to guide surgeon to put the right place and the cut in the right place. And after the surgery, you can see that all of your measurements, analysis, and planning really helps in the operation room, and it cuts the surgery time a lot of time. So this is one of the similar, but the thing is that we can also make some jaw analysis, the movement analysis. So in order to understand the surgery that we plan to do, it's really going to work or not. You can understand by doing different analysis over the Mimics Innovation Suite. So the another one is quite similar. So I will skip those. But the important thing is here that Mimics Innovation is a tool that you can do a lot of stuff. It is for mainly engineers, but there's also some tools for doctors and surgeons or clinicians. So everyone can benefit from this kind of softwares. So we also use this kind of birth anomalies, which causes a lot of asymmetry on the face. This was a foreigner patient, if I'm not mistaken. So we designed, or we planned, first of all, a surgery, and based off the plan, we designed a patient-specific implant, and this is how the patient will look like after the surgery. The another one of the hard cases, a suicide case. So basically, nose and the orbital section of the face is lost. So a patient-specific implant also designed and applied for this kind of patients. So there are more complex cases that we use the traditional way and the innovative ways in one hand, as you can see, and the different applications like a chest wall. Because of a big tumor on the bone, chest wall bone, we replaced this portion with a patient-specific hip implant, and these are some images from the surgeries. The another one, this is at those days, at least as far as I know, the biggest implant has been done in one time. So it's one of the most important one. So it's also important to surgeons to understand what kind of applications can be done, so that actually as engineers we are not the ones who can plan the surgery. So they know the techniques, they know what they can do, they know how the body reacts, and based on this information they can put more value with this technology, they can make multiple implants. They can use them custom-made plates or advanced surgery planning based on the surgeon's experience. So another one that they use some also stem cell. They also use some tissue transplantation and transplantation, and also planned dental implant as well. There are also some cases on the orthopedic industry, specifically for the revision and the reconstruction cases. I will skip those parts that I would like to show you the mimics. So this is how it works. The patient first go for a scanning. So when you put them on the top of each other, it's actually follow a path. So based on this path, we can you could say segment those images. It can be a bone, it can be a tumor, it can be a model or soft tissue or muscle, whatever it is. And after you have these models, you can do different things like 3D analysis. You can measure the bone quality, the distances, and the sizes and volumes. It really helps the people the professionals to understand what's happening in there. The another one is the finite element analysis. I mean, if you are going to apply a medical device, or not even medical device, if you would like to understand how their body will react during the walking or running, you can do this kind of finite element analysis modeling. What basically it does is it do this analysis for custom way. Another one is the surgical procedure, surgical planning. This is a pedicle screws that is being used for orthopedic spinal cases. They see where these pedicle screws are implanted, and this is what we do basically, an implant design. This one is a simple one, but even less experienced people can do that. And this is the 3D printing part. I mean, you directly send it to a desktop 3D printer. Whatever you planned, you can have it in your hand. So this is very, very important in the future treatments in terms of in the medical field. So these are, maybe I can a little bit show this one. So this is a case, a patient, so a windsurfer. He had I think, a competent arthritis and had a reconstruction, a failure one. So his bones needs to be reconstructed. So this is how the procedure happens. I mean, they take the CT scans, converted them to 3D models, and they do the surgery on the computer level so that they understand what's going to happen for different scenarios. For instance, they say that in order to have the right position, you need to have a 15-degree or 18-degree. You can even design a patient-specific trauma plate. You know what sizes of screws you need to use. And this is the guide. The guide is guiding the surgeon to cut in the right place. And they are all biocompatible material. So we use different kind of materials that can go into the surgery and sterilized or even in contact with the blood. And this is the procedure after the 3D printing. It looks a little bit messy, but it's not actually. When you have a hands-on training, you will understand that it's quite straightforward. Here are the final checks before going to operation. And this is the operation. So they place in the right place, screw it temporarily, and cut in the right place. Put the placement of the screws, and this is the surgery after planning. So based on this, we understand that having a couple of hours before the surgery really helping the patient's comfort. So another topic of today is the standardization of the 3D printing, which is a quite gap in the world. So still the medical regulations are not very strict, so there are some gaps in order to be filled with the professionals. So even in Turkey, in US, or in Europe, there are new procedures and new regulations should be implemented into. So this is one of the earlier studies of this is the first expo about the medical 3D printing, and we were one of these partners, like Clinic, Harvard, and Materialize, Stryker, and we were there. It was held in Dubai last year. And one of my final slides is that this is the Cyborg Sea Turtle. It's a case that we have done, and the one that I mentioned is inside the BBC Earth documentary and Discovery Channel documentary. So in my final slides, I know that Dr. Moon has better of this, but we are also interested with the augmented reality, virtual reality, and we have a partner in Turkey. So these models also can be converted for different applications. So it's a small video. Thanks for listening. If you have any question, I will be happy to answer.
Thank you.
Kutay. Any questions or comments?
Yes, very brilliant presentation. Thank you. My question is two or three. The one is, I know Meteorize company is going to something, lots of innovation, the studies and R&D project. So, do you have any plan to the flip from two-dimensional simple X-ray to three-dimensional the model? Another question is, still soft tissue modeling is still something the very tough issue. So is there when it is a little more improved by the mimics engineering?
Well, I mean, start with the first question. I mean, we are not really so much into software side, but we are part of a Materialize development team. So we are testing their initial softwares or modules before the launch. So there are a lot of improvements so far.
Yes,
you know, maybe you used to use that Mimics Innovations for in your previous workflow, but it's not just about the software, it's also about the techniques that you apply. I mean, when you know that there are different tools, when you merge them, you can really simplify the process, like for soft tissue to like 10 hours to 2 hours, it's also possible.
Yes.
And now they also put an option for scripting.
Okay.
So this really simplifies the process, or not the simplifies maybe, but putting in a straightforward way. When you run the script, all you need to do is the minor steps. So there's a lot of improvements. So I personally believe that this was also something that we discussed with the GE and Philips and Siemens, that in the near term, when you have a CT scan or MRI scan, I believe they will just put a button and they will get the 3D printing of whatever they need.
Yes, I agree with you. And any question? Maybe my last question.
Yes.
It is, whenever I doing medical 3D printing standard or 3D application standard, and I am also convener of ISTC 261, and their question is, why you are not working together with Materialize? So do you have any plan to have a standard work together with something global standard?
Well, I mean, we are doing a lot of, you could say, the mutual studies with various companies and academicians, but I think we need to accept that Materialize is a little bit closed to the other parties.
Yes, I went to Belgium. Yes.
Yeah.
Rebang.
Yeah, you know that. I mean, although we are some portion of the development team, you could say, still they're not very open to us to do these studies, because they have a huge team in the different countries like the Ukraine and I think in the Belgium and also in the Malaysia.
Okay.
I think around 1,200 people are working for them, and they believe that this team is sufficient enough to do a lot of stuff for them. I do not agree with them, but still for today it's the case.
Yes, at least we are still waiting for you.
Yes, thank you. We will be doing that. So thanks for listening. I will be around if you have any questions that you would like to ask me during the...
Okay, thank you. Actually, at 3 p.m., thank you so much. We will start. I want to give the microphone to Professor Moon. Standardization meeting of Medtrain 3D MOSIM collaboration with IEEE, EMBS 3D based medical application working group meeting. So please, Professor Moon.
Yes. Okay. Thank you for coming, and thank you, Alberto. It's great pleasure to meet you again. And in last June actually, we have a meeting in Czech Republic and about the issue of new PAR. Doctor, what is our new PAR for our? Okay, please.
Testleri alın değil mi?
Maybe almost all you are new about this standard issue. So PAR means project. So new PAR means new project for standard.
Okay. First of all, I would like to
Please.
show our agenda today. And IEEE 3 based medical application working group meeting. It's on time now. We are starting at 3 o'clock at 3 p.m. Istanbul time. And this is our agenda, and we will follow up. Dr. Moon is the chairman, and I'm presenting vice chair with the sponsor chair, Carol Curry. I would like to show the new PARS proposal that we prepared recently. Maybe Professor Moon can add more, but I only have now 4 project assignment requests. Yes.
Yes. Last meeting, our issue was new project, which was about the 2 issues. The one, simulation. The another is printing. As you know, 3D printing part is a little something broad area, so we are a little chopping for each the part. The soft tissue simulation and hard tissue simulation. And about 3D printing, we are doing soft tissue printing, hard tissue printing, and bio printings. So, or implant and guide printings also. So we need to divide into each session, because medical 3D printing issue is a little something, the ocean-like broad the portion. So before we start our meeting now, we need agreement from our members. So is there anybody who is the positive move for the formal agenda? Alberto?
Accepted? Agreed.
Yes. Thank you. First hand, are you?
Okay. I would like to now show the first project assignment request. The title is Standard for Soft Tissue Bio-Computer-Aided Design File Format for Medical 3-Dimensional Printing. This is our first. And
No, Dr. Yuri, you should agreement first. And
Yes.
he's agreed. Are you agree?
yes,
Yes.
we are all.
Yes. 2 agreement without objection, so motion passed. Thank you. Then you can
Okay. And this is our scope for this project assignment request. This standard reduces the 3D printing output variability of soft tissue in medical images and defines a defined model data file, a format standard for consistent 3D printing. And standardization involves acquiring model data with physical density and size characteristic through medical tomography, image calibration, and developing digital file format data using image segmentation technology. Actually, this was my proposal to you,
Yes.
Professor Moon. I only proposed to Dr. Moon can be created in conjunction with the project, but that has highly valuable experience on soft tissue 3D modeling. And that probably you created the last version of this PAR.
Yes.
Okay.
About this new project, Dr. Yuri, my vice chair, want a little focus on the urology simulation and urology part printing. So there's 2 ways. The one is change the part 2 into the neurology. You can change the title itself.
Yes.
or you can be a subdivision of soft tissue, the printing.
Yes.
But most convenient technical point way would be the change the title of the second part directly.
Actually, I would like to inform about these details more because what was my proposal to the IEEE working group about that. Especially, we have a really big hub in international urology section. So 2 months ago, I participated in a meeting in Turin, in Italy, with my urologist colleagues, and they are also interested in the 3D medical standardization in urology section. And I proposed to working group how we can create subgroup under the group of this group to create a urology section, 3D based urology section, international standardization working group. So this is Catherine Bennett from IEEE suggested me, you can give a new project assignment request. It can be feasible, but after Professor Moon sent this proposal, and I just wonder if we can adapt the urology section into this, because this is a really wide and there's a big group. The soft tissue BioCAD it includes the urology, surgery, and everything related soft tissue, maybe apart from the orthopedic surgery, because this completely contrasts. So this is why I proposed to you, and then in my opinion, to go ahead with this topic will be the best, not only the urology but also the all surgical sections which are related to soft tissue demonstration.
Yes, my opinion is you can make a castle in this part.
Yes.
You make your boundary, urology boundary.
Yes.
In the soft tissue.
In the soft
simulation and soft tissue printing.
Yes.
Then yes, most of this part can occupy by urology part.
Yes.
So you can do everything in this area, because if you make a new part, you need to our
Spread.
energy is spread.
Yes, I totally agree with you.
Let's
Yes.
concentrate.
Yes. So I think this is very good improvement for us. Why? Please, the podium is for everywhere. Please talk you and give or, because this is, we will write our minutes according to your comments, and we will at the end of the meeting. And so I think this is very good how we are at the right way, because now as you see from the presentation of Kuntay, his presentation mostly related to bone, mostly not mostly, totally. So we need to make it the better and the best for soft tissue, intra-abdominal organ, especially maybe the intracranial. So that's why I think I totally agree with you, the Professor Moon. After acceptance of this new part by the IEEE, if the group is accept, and then the urology can be one of the maybe the section. Maybe the new proposal can come from other sections.
You can modify the part for more take advantage for your urology part. In this, yeah,
we can do it.
Yes, you can.
Okay, with
you
pleasure.
Can modify.
Okay.
Alberto, I invite your opinion. You agree? Yes.
Thank you. Okay. The group is agree. We can go forward
Yes.
this part.
I have a question to the check. How about the liver? Liver is also very the important vital organ. So
I think yes, Dr. Moon, we can maybe the urology can be one of the, but maybe surgical procedures, some surgical organs, because we believe that especially in our section, this project showed us the urological organs are very suitable for virtual reality and also the printing, and maybe we can modify it.
yes, today our mission of this discussion, this meeting, is division of new parts, and you need to approve from the center of the IEEE and ISA, EMBC. Another one is about urology specific the part. So you can make the soft tissue printing and simulation as a neurology standardization.
Özer?
Please,
Microphone, please.
can you summarize?
Okay, it works. Hello, everyone. As yesterday we talked with John and Miroslav, I think LISA system and the 3D printed versions of the solid organs are prone to improvements. But if we can take a deeper look to inside of the solid organs, we see that liver is prone to improvement in combining the bile tree and vascularity. On the other hand, the kidneys should be combined with urinary collective system and vascularity. So the complications and surgical approach would be different. Therefore, I propose a group who are specially working on liver printing, which may in the future give rise to combining bile tree and vascular system and experimental surgery in the future. And another group will work on the kidney and liver collecting system.
Yes, very, very good, good comment. You are right. We can produce subdivision by one, as a kidney itself, urinary system, or other system, other tissue too. But in such a point, we can make something technical, the report, because, for example, this is a mouse. We cannot make each something, the accessories, the standard. Our issue is how much resolution is required for this mouse, and how much power is needed for modulating this mouse, like this. So if we produce soft tissue engineering or urinary system standard, then the final mission is how it is useful for the surgeon and the patient, and how it's accurate as real urinary system.
Yes.
That's our first issue. So, if we require a more detail, we add some sub-branches as a technical report. Yes, that's the way of solution for more something accurate or detailed part. Yes, main theme and small branches.
Yes. Dr. Moon, actually, we have 4 parts, so I agree to Özer.
Yes.
Because in my opinion, that's why, because of my international partners, urology colleagues, they are also interested in, but they are not here. Because, of course, we aim to create a big family, especially in urology section, because of we really started to do lots of job in urology. If the group agree, we can modify this project.
Yes, soft tissue engineering.
Soft tissue, we can add soft tissue,
yes.
But maybe the global, the common name, the standard for soft tissue, the BioCAD file format for urological 3-dimensional printing. Okay?
That's good.
Agree?
Yes.
Okay?
Yes.
It's agreed.
Yes.
May
Tissue engineering in
soft-
urologic.
and
yes.
urologic, yes,
Yes.
printing.
In, yes.
In,
urologic,
yes. And by the way, we can create a big group in the world. But of course, in urology, it includes the urogynecology, urologic surgery related to surgery, surgeons, pelvic surgery. It's not only the, of course, but this is and also neurosurgery, like sacral neuromodulation. So, because we need to publish the standards, it's important. So, of course, we are a big group here, but we are not enough for us. We have many colleagues, and they are really waiting for this meeting, okay, the approval. So I'd like to thank you on behalf of my colleagues also.
Yes. So, as a standard specialist, my advice for this issue is you should be something like we should have a broad range rather than small n for our life. Standard require a little something, the broad issue.
This is the second project assignment request to IEEE, standard for surgical guide template by medical 3D three-dimensional printing. And this is some descriptions and some information and a little bit mini scope. This standard defines the file format for three-dimensional printing based on materials of 3D model for the surgical guide and the surgical guide template needed by the surgeon. Maybe it will be enough for us because it's very summary. Probably, in my opinion, it's okay when I read it. It's completely needed.
Okay.
Some guides, some materials can be produced using the 3D printing. Of course, we are in urology using probably the other sections. Neurosurgeons are using some guides. Okay.
Urology also require guide system, right?
Yes. Tomorrow we will use.
Yes.
But it's not 3D printed. We will use some brands, but not common. So this is, I think, very, very good. We have some papers coming from various colleagues related to guide wire 3D printing producing, but only experimental.
Okay.
Everybody agree this project? Hands? Okay. The third one is standard for implant BioCAD file format for medical three-dimensional printing, mostly related to implants. And here is the scope. This standard defines the 3D implant model, data, and the file format for 3D printing based on the implant templates and materials required by the physician, mainly related to the orthopedic surgery, patient customized implant model. Now we're on podium. Dr. Moon, you want to say something about that? For implants?
Yes.
Maybe the implants and guides completely different.
Absolutely.
But I just wondered about the implant. For example, Kuntai showed us some implant material, some for bone, especially on a head and or any other the region of the body. And this is because I'm working in this group a year before a year. Don't you standardize the implant models? This is the first time, Dr. Moon?
Exactly the first time.
It's the first time.
Yes.
Okay. It means that everybody produce something, but probably without standardization.
Without standard.
Okay.
Yes.
This is, I think, the main problem we have to tackle out. Okay. This
Yes.
agreed. Silence is the agreement, probably. Thank you. Okay. The last project. Oh, this is the same urological. Okay. The standard for hard tissue BioCAD file format for medical three-dimensional printing. We discussed about the soft tissue, and this is the hard tissue. Scope. This standard defines a data file format standard that increases the precision of 3D printing model output of hard tissues in the medical images. Standardization involves the use of medical scanning devices to acquire physical data models and density and size characteristics and to develop comparative analysis data. Dr. Moon, any words wants to say about the hard tissue? We know the bone, it's only the bone, hard tissue.
Renal stone.
Renal stone, okay, yes.
So we have a lots of hard stone, hard tissue in our body, not only the bone, cartilage, and the stone or the calcific material in our something, the human the body also related together, matching point together with implant, and this hard tissue is mandatory process for this the hard tissue the printing.
Okay. Any words, any comments, any questions, or Any discussions about the hard tissue?
One issue is we need to eliminate file format issue. It's just 3D printing for hard soft tissue and 3D printing for hard tissue. File format is something specialized. So the materials company already promote such the file format system and modeling. So we are going to more practical way
Yes.
for 3D printing and for implant, 3D printing for urologic soft tissue, and 3D printing for the implant guided system, and 3D printing for implant. That's more correct word.
Right.
Straightforward.
Dr. Moon, I totally agree with you because as you remember, we talked in July meeting, in June or July meeting in Pilsen. We have to because in this project we followed the one vision. We separated the groups who will works for 3D printing, who will works for VR simulation.
Yes.
So we, at the end of the day, we achieved. It means that this is the right way we can go forward. The second one, but we have to decide which one should be the first. We have to first go on the 3D printing or 3D simulation, according the data, based on our patient data. In my opinion, according to the definition of the academia, first of all, research, teaching, and patient care. At the end of the day, the patient care should be our focus. But at that moment, we have to think about, first of all, for the standardization, the 3D printing will be the first, or the 3D simulation will be the second one, or vice versa. In my opinion, the most important issue is 3D modeling. And the 3D modeling will provide us to create the real model for the patient-specific therapy or some surgical planning. And then 3D printing can be really valuable for us, especially 3D printing, processing, and polishing, as you defined in previous meeting. So I think the division of the VR simulation and 3D printing is very efficient. We are at the right way. In my section, in urology section, I look for the most of the urologists, probably as an international European friends, mostly related to Italian colleagues in urology section, and they are really keen to make some 3D printing models for training purposes. But the most important issue, how we can adapt the soft tissue 3D printing into the gross surgical procedures for soft tissue replacement, reconstruction. I'm not talking about the tissue engineering, please. No, not tissue engineering. It's completely different. So I think we can, after standardization, this is the reason for, I think it's very important for the standards. Maybe our group can really work on to really immediately write the standards for soft tissue printing, and then publish some papers according to some organs, and we can work on reconstructive surgical procedures for 3D printed version. Because maybe I showed you some slides regarding the sacral neurostimulation, that you can see there is a really helpfulness of the CE arm to use the needle, but today, I know that I can use the CT scan of pelvic region, use the bone scan, and to really create a 3D printed material. Without C-arm, I can put the needle into the sacrum according to the patient-specific data. This is I think, as I mentioned, as I want to say that we have to. I think we should use our data efficiently. Because it's really valuable for us. And I just want to learn your comment, because maybe today, our group meeting, we can maybe decide to make the standards. For example, in 2 months, 3 months, 4 months, maybe we can
this is the project assignment request. Of course, we will maybe in a week we can revise according due to this group proposals, and after their acceptance, can we make a limitation duration time for the writings creating the standards?
Before we decide propose our 3D this standard, we should answer 3 questions. The one, why we need this standard. Second, what to do for this standard. And final, how to do. Why, what we need for this why, and how to do technologically. So how much resolution is required? How much softness is required? And who is user? Patient, you, or company? So, and what is our product for this standard? So you should summarize this point. That's the major issue of standard.
I totally agree with you, Dr. Moon. For example, why, how, and what, it's important.
Yes.
Of course, we have to follow the evidence-based medicine.
Yes.
You know, and now we are writing an article for Turkish Journal of Medical Science. It's one of the prestigious journal of Turkey as an international fashion. So it is important. We are now search all publications related to urological 3D printing, and then we go forward, just discuss our materials with the literature outputs. So I think we can start in this group. That's the reason for why we will propose the PAR. Immediately we will create the international committee, okay, who will, because the big data is very important. We have to create the big data on soft tissue 3D printing, big data of, so probably maybe we can also get some help from the companies like Materialize or any other companies, and then the written is writing the standardization. By the way, will be not so difficult for us if we have a big data of the outputs.
Exactly.
Kuntay, what do you think about that? I know you don't listen me, but I will repeat for you. We are just talking about the soft tissue 3D medical standardization. And because today, especially in urological section, we agreed to propose to IEEE. And Professor Moon said that, first of all, we have to define the why we will do it, how we will do, and for what to do. And so I propose that we can create a big data for the evidence-based data, and then we can get support from the company, the company's outcomes, for example, mostly related to heart tissue, because your experience are related to heart tissue, and we want to convert into the soft tissue. So maybe, and then we can go forward. What is your opinion?
Well, I believe it would be hard as a first glance. I mean, it will be hard to get those information from those companies.
Not all companies, from you.
For big data, I don't think that we have enough information, because for big data is another concept and it's a huge project. So
Yes.
you need to have really different centralized information from.
Is there any hub for of Materialize?
No, I don't think so. I don't think that there is enough information globally in one company, because the big data is, I think, as far as I know, we need to have huge data.
You're right. The published articles and approved data is enough.
Yes, enough.
Make
Yes,
sense.
yes. I mentioned.
You can analyze your already published and
Yes.
approved data.
Yes. Probably you misunderstand me. Big data. I know the big data means like the definition is like your definition, but I just want to say, and the literatures, the publications, and personal experience.
Yes.
Maybe you can
Yeah,
put your
that will be a good way
own
to start.
know-how on
Yeah.
personal experience.
I mean, I believe it will be a multidisciplinary study because, as engineers, we know something about how to do that, but we need to validate if it's really right format or right, you could say, the model that a surgeon or a professional needs. So it should be a multidisciplinary study.
That's great. Thank you.
You're welcome.
Thank you. Dr. Moon, our agenda shows probably there is an liaison. You are the liaison between IEEE and ISO. If you want, you can give some information to us.
Yes. Personally, from last December, I am selected as a convener of ISO TIS 261. So I cordially want working together with this IEEE for promote this IEEE group into global the standard group. As you know, IEEE is a little something the focus on North America. So if we working together with ISO, it is more something, yes, more symbolic the process together with the global standard organization. That's why I am asking if there is liaison together with ISO and IEEE about 3D printing issue. Alberto,
Okay, Alberto?
suggestion?
Microphone, please. Any suggestion? Any suggestion?
I actually would like to ask for a possible, for another sub-project to be before soft tissue printing. That is 3D soft tissue modeling. You said several times that 3D modeling is the root of everything in this sector. And I actually believe that it should be important to standardize the definition of big data for soft tissue medical, of course, applications. So soft tissue 3D modeling, soft tissue 3D printing, soft tissue 3D simulation. That of course is the last period, is the more distant topic to complete.
Yes, great idea. 3D modeling issue is 2.1. It is published as a recommended guide. It is published as a recommended guideline 3 years ago. So we can renew as a something division for soft tissue modeling and hard tissue modeling, like this. So yes, let's think it over. For we are going to Hawaii together with the URI for something, propose a new part. So at the time, we can discuss together with Carol, who is manager of the IEEE. So good idea. Another question is, we are going to connection. Maybe a connection together with IEEE and ISO. So is it okay?
Absolutely, that is a very good idea.
So
Yes, yes, because of the ISO standardization model is the more important in the world, of
I
course.
appreciate it. Thank you for your.
Yes, I agree.
I continue.
The next item is new item proposal, if any.
Yes, Dr. Alberto proposed new item about the divide.
Okay.
2.1, there is recommended guideline for 3D modeling. And
Yes,
one
3D
divide.
model. Yeah.
Hard tissue modeling and soft tissue modeling, right?
Sure.
Yes, good.
Hard tissue, but we
actually-
already divide the two part.
Yes.
Hard tissue and soft tissue.
No, about the modeling.
Modeling
About
is
modeling. Okay.
in general.
Modeling technique.
Because
Yes.
Okay,
actually,
I understand.
Yes.
Because probably you already
Published in the-
published
Because-
hard tissue.
Yes,
Okay.
even though it's the 3D model.
actually, there are tissues are just an extreme realization of soft tissues. I
Okay, yes.
believe that we should converge on soft tissues with this general topic and not to separate hard tissues.
I think-
It doesn't make sense for me.
Great.
It's just an extreme realization.
And
Moltograph-
The same data should work for both.
okay, maybe. Okay, I just
The same
this-
data
this-
representation.
This is really This is really, I think, good proposal. In my opinion, this should be the second one. For example, why? Because this will be the new part.
No. I mean,
We will add
proposal means
Okay.
we can ask to the.
We can ask to.
about this.
Okay.
And then the Carol will the
Okay.
answer.
Okay. And I have. I would like to present also our university, Hacettepe University, IEEE EMBS section. If you permit me, our group is probably.
Dr. Yuri,
Sorry.
just please say one by one.
Yes, one by one. But they will introduce themselves, but not today, but probably during these 2 days or 3 days, 16 participants were here, probably for many reasons. We have a little bit few, but the managers are here. IEEE MBS Hacettepe section, Hacettepe University section.
Okay.
I am the one of the advisor of the group. I would like to introduce the isim neydi? Şevval, who will present something about that.
That's great. Please come confront.
Okay. Hi, I am one of the global member of EMBS. As EMBS Hacettepe, our first aim is bringing professionals to on amateurs level to interact with. In that case, our student representative Ismail Aslan and our mentor MD PhD Emre Huri provide us a place to innovation to our society. In EMBS Hacettepe, we have various type of students as engineer and medicine. So we should work on a multidiscipline area. As EMBS Hacettepe, we are providing our members workshops and chance to internship with some companies. Also, we are interested in brain-computer interface and 3D modeling, 3D organ modeling. We aim to use an integrated circuit to process brain signal to deliver a bionic hand in second term. And also our mentor Huri provides us mimics modeling lessons to 3D model. So.
Great, thank you.
That's good.
That's good. Dr. Moon, I have a proposal, and our young scientists, I defined them like that. They are so keen to work IEEE EMBS, the working group, 3D-based medical application. The suggestion to the podium to one of the collaborators as a student branch, maybe it can be the first, I don't know if there is some collaborators of working group, the IEEE Hacettepe, EMBS Hacettepe section can be one of the collaborator of IEEE working group, 3D-based medical application working group, my proposal.
It's good.
Agree?
Alberto, are you okay?
Okay.
Yes. He's
Okay.
very major
Okay.
decision maker. So
Okay. Okay. And next steps, homework. Probably we have some homeworks. we will do
So,
after the meeting, and
Emily, we need something modify the PAR for easily accept in the IEEE and EMB the center. So
Okay.
we should do something more the very correct English.
Okay.
And then
Okay.
polishing
Okay.
our article, our suggestion.
this parts
Yeah, this
you
part.
mentioned. Okay, we will modify it.
Yes, modify for
Okay.
why, what,
What?
how.
Okay.
Yes.
Okay.
And then we can submit again.
Okay. Okay. And next meeting schedule and venue. Any proposal?
Yes. Let's see you in Rome meeting.
Yes, I totally agree. Yes, the Rome meeting, and probably today we will discuss more about the Rome meeting, the project meeting, and the IEEE meeting, and probably we can make it international fashion
Yes.
with the web conference, and we can prepare it earlier.
Yes.
And the date will be the date is probably we already decide, but today we can discuss it. Okay, for closure.
Thank you everybody. Thank you everybody, and enjoy your night. Thank you.
Okay. And thank you so much. Today we finished the agenda. So we would like to, on behalf of the MedTrain 3D ModSim project partners, I would like to thank to you all for participation at the third day of the meeting. For tomorrow at 10 o'clock, please advise your friends advise at 10 o'clock. We will start the hands-on training session at 10 o'clock. And this part is the unique part. I can define it. That is the widest and the extended 3D printed and VR urological and surgical model hub. This is the first. We will make 11 stations. In 11 stations, each participant can try to make 45 procedures. And you never did, do in your daily life. So these sessions are open to all of you, not only the students, residents, specialists, the professors, for us also, because why? These models are you will use for us, for the all member of the projects, and we will check the points and remark your success. I believe that everybody will be success, but probably not the same success fullness. So we will report it and we will publish the results. And thank you again for participation at our meeting. See you tomorrow at 10 a.m. At 10 o'clock, we will say good morning. Thank you.